Part of my time at Microsoft was spent managing an technical team. I was dev lead, uh, called the Open Source Technology Center, and we had responsibility for this thing called the System Center family of products. And we were the Unix and Linux team. We implemented the Unix and Linux drivers and agents that System Center needed across 42 different Unix and Linux platforms. And I was personally responsible for a thing called the System Center Configuration Manager, which is used by large organizations, including Target and Home Depot, the Army, uh, to manage large distributed networks, uh, you know, across across the internet, and it's all done by policy and REST and exchanging messages like crazy through the HTTP services and things like that. And yeah, so that's where I got a lot of the background that I use in creating the entire FrogNet architecture in terms of uh, the ability, the way that the policy system works, right? But the point is that I have a pretty good idea of what it takes to monitor a machine, and when I say what it takes, I mean what it takes in terms of REST calls. You know, you have to have servers, you have to have databases set up, you have to have handlers in the REST system. There's all kinds of things you have to do, and the part of actually managing the computer is really less than half of what you've got to deal with. The vast majority of my time was spent dealing with screwed up messaging, and so I knew that when one of the first things that I needed to do was implement a way for me to monitor what's going on across my network, but I wasn't going to do that by exchanging huge amounts of data through REST servers. I was going to use FrogNet Memory, and that's exactly what we do. So each machine, as it's running, is just writing what it knows. It's writing its own state into the FrogNet memory, and the monitor just reads it. Right? There's no messaging that has to go on in between everything or anything. It's just in and out of FrogNet memory in its own time, the producer and the consumer. And so that's what the FrogNet Monitor is. It is a view into the FrogNet memory that is current and from the perspective of the machine that we're running on. So these two actually are the same machine as it turns out. I just noticed that. Sorry, let's do this one. Uh, it takes it a second to come up because it is connecting to the database and gathering the first sets of information. Right, it's hooking up to FrogNet memory, and this one actually. Let me use New York because this one will work, but for some reason, and I'm not sure why, it's not getting. And I stand corrected. It was just taking longer than it should have. Uh, so it is connected. When it comes up without having these little blue uh, links down at the bottom, that means it's having trouble connecting to the primary database. And When that happens, it usually means there's some sort of a network congestion, and that's when I'm going to go and analyze the log files. So I'm going to be doing that after I get done with this demonstration. But what we're looking at is two different views into the FrogNet shared memory, right? From this guy's point of view, Seattle 5, everybody's groovy, online, 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 online. From this guy's point of view, Seattle 6, I've got some degraded and I've got some flaky. That doesn't necessarily mean there's any really any problem, but that combined with the length of time it took me to bring up the detail here indicates to me that there is some sort of problem going on here. So I'm going to have to take a look at that. But nonetheless, it still got in there, right? It gathers the data. And the interesting part is that I can come in here, right, and I can see, I'm going to select Seattle 2 here. And when I select it, I see the sensors for Seattle 2. Now the sensors are running on the machine. The data gathering is on the machine and it's just writing it into tuple space, right, in FrogNet Memory. But everything is being written in as, this is this sensor, this is that sensor. The tuples are the sensor name, the sensor type, and the sensor location. So we can see we've got the semantic cache, and then we've got its peer, and then the location is, the 10.30, 10.1. And we can pull that down and open it up. And this is the JSON string that is at that memory location, right? So this is raw JSON that is being pulled up, and we can do the same thing up here, right? Seattle 2 and semantic cache. Which one? 102.60? Yeah. So we can look at it here and see, okay, so it's got the same frog ID, right? So this is the same memory. And I just randomly pulled it up, right? There was no coordination here. I didn't have a central server. It's just reading what's in FrogNet Memory. And I can tell you now, I just hit the queue here. This machine is, there's either something wrong with this machine or I've got something going on with the network, but it's definitely degraded. So I'm going to stop playing with this one. And this is New York. So let's take a look at New York. I don't want to mess with the other one while I'm, until I can get at its log files. So in New York, it's the same thing though, right? I'm just gathering the same data, right? The same frog ID. So that's what the monitor is, right? So all of that stuff that I was doing at with Microsoft, where we were, having all the coordination from all the machines, where I had to have my agent be able to do things based on what was coming into me. A lot of that goes away, right? It's just a different paradigm. It's a new way of doing what we do that gets rid of this whole layer of what is really the most fragile and time-consuming part of being a network programmer. And I say that as somebody who has spent many, many hours debugging this kind of network code. Being able to do something like this without having those kinds of exchanges, right? I mean, what you're looking at is JSON, that is the data element. So it's a tuple space and it points to a JSON bag. And you define what the tuples are and you define what's in the bag. All we're doing is facilitating your storage and retrieval, right? So it could be that it is, program name, variable, and then like user ID or whatever your identifier is, right? And then you just have different programs running across the network. Just say, give me that, and you can search by tuple, you know, tuple type or tuple name, right? So that's how we get, these are the sensors for Seattle 2 versus these are the sensors for New York 1, right? Different query, right? But it's just memory, right? That's all. It's just memory. So that's the big change, right? It's not anything huge. It's we do this kind of network programming. We do this kind of programming on a single machine, and we use shared memory there. Or what we do is we do it with you know uh, like a database, right? And it's a network database, and it's heavy duty and all this kind of stuff. No, this is easier than that, right? It's just you make the call and it happens, right? Anyway, uh, oh yeah, the one other thing that happens here. This is very cool because you see this. This is a live map of my network, right? And these are the network connections in between them. It's not all the connections. This isn't quite right, but it's very close. This is being read from the tuple space as well, right? And this is real time, right? How many times have you wanted to just map your network? Just say show me what my network looks like, right? This is it, and all I had to do was query uh, you know query tuple space, right? So what sensors do I want to read, right? What memory do I want to load, and this is the result, right? And it's the same thing here. I can get the, sorry about the font and everything, but I can look at it, and this is the JSON that is that sensor, right? Uh, for BA box, right, or Seattle 2, I can look at it and say, here's my link cache, right? One of the things I do have here, let's see, system, yeah, the perf. Oh, that's interesting. Okay, never mind. If we look at it here, uh, it's obviously not rendering it right. Let me see, because if we come down here, perf, this is what's in perf. This is the kind of stuff that I was gathering for System Center, right? This is the disk I/O, right? Below this is the memory. Below that is networking, I believe. Yeah, see, here's the host, the networking, right? All that, and this is a snapshot of the machine as it sits right now. We could also inventory the machine in terms of what software is on it, uh, all that kind of stuff. We can set, in terms of what I would do if I were redoing System Center this way. I would say set memory, and if you want me to do something, instead of sending me a message that says do it, just set memory that says this needs to happen, and I will see it and I will go out and do it. Right, the same as is just like we were within the same program, threads within the same program, right? You send a signal, right? You set a semaphore. It's the same thing. We can build that kind of stuff now that we have a a language above assembler, right? That's the whole thing. Is that this is a way that is, it takes away, just like C replaced assembler. I mean, it didn't replace assembler; it uses assembler, right? And it made it so that more people could use the system, right? Because I don't know if you ever tried to write assembler, but I have, and man, it's like wackadoodle weird. Uh, but you have exquisite control of what's going on, right? C writes all that assembler for you, and you lose some of that exquisite control, but you gain so much more, right? And that's what the FrogNet Memory does for you. So anyway, I will stop preaching now and wish you all a good day. Thanks for watching. All right, bye.